Welcome to Astronomy Daily, your essential guide to the cosmos. I'm Anna, ready to explore the latest celestial happenings.
And I'm Avery, joining you with today's headlines. We have some truly fascinating stories lined up, from groundbreaking new methods for detecting gravitational waves to surprising discoveries about the water content of distant exoplanets.
Indeed. We'll also cover a recent very close asteroid flyby that you might have missed and get an update on Australia's growing space industry with Gilmour Space Technologies. It's a packed show, so let's get started. Our first stop takes us to the cutting edge of physics with an exciting new proposal for detecting gravitational waves. These ripples in space-time predicted by Einstein are notoriously elusive.
That's right, Anna. Physicists have put forward a novel approach to detect what they call mid-band gravitational waves, operating between 0.001 and 1 hertz. This is a frequency range that existing instruments just can't reach effectively.
And these mid-band waves are crucial because they're generated by fascinating systems like binary white dwarfs and neutron stars within our own Milky Way, as well as the mergers of massive black holes. What's the secret to this new detection method?
It relies on optical resonator technology, originally designed for highly precise optical atomic clocks. Dr. Vera Guerrera from the University of Birmingham highlights that this extends our detection capabilities into a new frequency range using instruments that are laboratory-sized.
Laboratory-sized? That's quite a departure from the massive LIGO and Virgo interferometers we're familiar with. This could open up a whole new realm of possibilities, perhaps even a global network of detectors sooner than anticipated.
Precisely. The proposed system uses two optical cavities, essentially mirrors bouncing laser light back and forth, placed at right angles. While mid-band gravitational waves don't deform the rigid cavity spacer, they subtly alter the phase of the light itself. And here's the genius part. State-of-the-art optical cavities are already sensitive enough to pick up these minute changes.
So it's about exploiting existing supersensitive tech for a new purpose. Professor Xavier Calmette from the University of Sussex added that this detector will allow us to test astrophysical models of binary systems, explore massive black hole mergers, and even search for stochastic backgrounds from the early universe. Truly phenomenal.
Indeed, while large space-based laser interferometers like LISA are still about a decade away, this optical cavity detector offers an immediate and cost-effective ground-based solution for mid-band exploration. It may be less sensitive, but its immediacy makes it a game-changer. Okay. Moving from the ripples of space-time to the surfaces of distant worlds, we have new research challenging our understanding of exoplanets, specifically their water content. It seems the universe might be a bit drier than we once thought.
This is a big one, Avery. For years, theories have suggested that many exoplanets, particularly sub-Neptunes like K2-18b, could be entirely covered by deep global oceans, making them potentially habitable. These were often dubbed Hycean planets, a portmanteau of hydrogen and ocean, assuming vast amounts of water.
Exactly. Sub-Neptunes are larger than Earth but smaller than Neptune. Very common in our galaxy but absent from our own solar system. Many are thought to have formed far from their stars, beyond the snow line, accumulating ice before migrating closer. The prevailing idea was that they'd retain a massive water envelope.
However, this new study, led by ETH Zurich and published in the astrophysical journal Letters, introduces a crucial factor: chemical coupling between the planet's atmosphere and its interior. Caroline Dorn, professor of exoplanets at ETH Zurich, put it quite directly. Water on planets is much more limited than previously believed.
The researchers simulated sub-Neptunes going through a deep, hot magma ocean phase with a hydrogen gas shell. Their computer models show that during this phase, chemical processes actually destroy most H2O water molecules. The hydrogen and oxygen atoms attach to metallic compounds and disappear into the planet's core. The conclusion is stark. Any water remaining on the surface is likely limited to just a few % at most.
That dramatically changes our perspective on habitability. If these larger exoplanets are far drier than we imagined, it makes the search for extraterrestrial life even more challenging. Conditions suitable for liquid water would likely only exist on smaller planets. and even those would require better telescopes than James Webb to observe clearly.
Indeed. And here's a paradox. The study suggests that the most water-rich atmospheres might actually be found on planets formed within the snow line, where water wasn't initially accumulated ice, but rather produced chemically from hydrogen reacting with oxygen from silicates in the magma ocean. It challenges the classic link between ice-rich formation and water-rich atmospheres, emphasizing the role of magma ocean-atmosphere equilibrium.
A truly fascinating insight. So, rather than being extraordinary, Earth might just appear as a typical planet in this new model, that in reality, we may not be as unique as we previously thought we were. This kind of research is critical for refining our understanding of planetary formation and the conditions for life in the vastness of space. Now let's turn our attention closer to home, though still in space. There was a recent celestial visitor that made quite a close approach to Earth, largely unnoticed by the general public.
That's right, Anna. A small asteroid, designated 2025 TF, safely zipped past Earth on Tuesday, September 30th, at approximately 8:49 p.m. EDT. Its closest approach was roughly 250 miles, or 400 kilometers, above our planet's surface.
For context, that's about the same altitude as the International Space Station. It wasn't a record, as asteroid 2020 VT4 flew by even closer at 230 miles 5 years ago, but still an incredibly close shave.
Indeed. And how big was this particular cosmic pebble? 2025 TF is estimated to be about the size of a couch, roughly 1.2 to 2.7 meters in diameter. Interestingly, astronomers only spotted it a few hours after its closest approach, with the Catalina Sky Survey being the first to detect it.
That's a testament to how challenging these smaller objects are to track, especially when they come from the sunward direction. Due to a government shutdown, NASA hasn't issued a formal statement, but data from JPL's CNEOS confirmed a nominal distance of 4,213 miles from Earth's center, which corresponds to that 262-mile altitude over Antarctica.
While NASA meticulously monitors larger asteroids that could pose a threat, smaller rocks like 2025 TF are much harder to spot. However, our technology is constantly improving, and such close, safe passes are now being detected several times a week. It's a reminder of the dynamic nature of our solar neighborhood. Finally today, let's head down under for an update on Australia's burgeoning space industry. Gilmour Space Technologies recently made its first orbital launch attempt for its Ares small launch vehicle.
And while that launch attempt on July 30th lasted only a few seconds, 14 to be precise, the company is surprisingly satisfied with the outcome and is already planning a return to flight next year. CEO Adam Gilmour stated that while the rocket was in flight for only 14 seconds and its engines fired for 23 seconds, it still provided invaluable data for their next-generation rockets.
That's certainly a pragmatic outlook after what sounds like a less-than-ideal initial launch. Gilmour Space is investigating the root cause, suspecting an issue that wasn't sufficiently tested under conditions closer to actual launch. But a significant factor in this first launch was an 18-month delay between shipping the rocket and the actual launch.
18 months is an enormous delay for any space company. This was largely due to regulatory approvals, an astounding 24 permits from the Queensland government alone, plus approvals from the Australian Space Agency, airspace, maritime, and environmental permits. Adam Gilmour openly admitted they hadn't adequately resourced those complex regulatory processes and regretted not doing more testing during those prolonged delays.
An incredible bureaucratic hurdle. Despite the very short flight, he was quite pleased it even managed to get off the pad, candidly referring to it as an old, clunky rocket by the time it finally flew. It speaks volumes about the challenges of pioneering a new space launch capability.
Absolutely. However, Gilmour Space anticipates a much smoother regulatory process for future launches after productive meetings with the Australian Space Agency. Now that they've navigated the initial complexities, he remains confident in future launches, aiming to provide a reliable domestic launch capability.
And importantly, the company is well capitalized, planning to launch again next year.
This is a crucial step for Australia as Gilmour Space Technologies is a key player in fostering a growing and competitive Australian space industry on the global stage.
What a journey through the cosmos today, Avery. From the subtle dance of gravitational waves to the surprisingly dry interiors of exoplanets, and from a close call with an asteroid to the determined efforts of Gilmour Space, it's been an episode packed with discoveries.
Indeed, Anna. It's a vivid reminder of how quickly our understanding of the universe is evolving. Each new piece of research, whether it's about detecting unseen forces or rethinking planetary formation, pushes the boundaries of human knowledge a little further.
And it's not just the scientific discoveries, Avery. It's also about the incredible ingenuity in how we pursue these discoveries. From laboratory-sized gravitational wave detectors to navigating complex regulatory landscapes for space launches. The human spirit of exploration is as vast as the cosmos itself.
That's beautifully put, Anna. This continuous push for knowledge, coupled with innovation in technology and even policy, truly underscores our inherent drive to understand our place in the universe. It's a journey that constantly redefines what's possible.
And that wraps up another episode of Astronomy Daily. Thank you for joining us on this exploration of the universe.
We hope you enjoyed delving into these stories with us. Don't forget to subscribe wherever you get your podcasts to stay updated with all the latest from beyond our blue planet. Until next time, keep looking up.